When 3I/Atlas swept past Mars in October 2025, it became clear that this wasn't just another comet. Its strange interstellar composition, ices older than Earth itself, and molecules possibly forged around other stars, hinted at a story written beyond the boundaries of our solar system. Now, as it accelerates toward Jupiter, scientists are bracing for a moment unlike any in modern astronomy. If you're still watching, subscribe now. You crave more than answers. You seek what lies beyond. Subscribe now and be part of the few who never stop searching. The European Space Agency's JUICE spacecraft, perfectly positioned near Jupiter's orbit, could soon record the comet's chemical fingerprint in unprecedented detail, possibly revealing compounds never before seen in our solar neighborhood. But with Jupiter's immense gravity looming ahead, the outcome is anything but certain. This next encounter could shatter Atlas into fragments or alter its path forever, rewriting everything we know about interstellar travelers. Whatever happens, Atlas's passage will mark a defining moment in humanity's study of the cosmos. Its hyperbolic orbit confirms that it came from another star system and will never return, making every observation between now and its departure in 2026 irreplaceable. Whether Jupiter tears it apart or allows it to glide safely onward, the data collected from telescopes, orbiters, and JUICE will echo for decades, offering insights into star formation, planetary chemistry, and the origins of life itself. For scientists across NASA, ESA, and beyond, this fleeting visitor is not just a comet, it's a messenger from the galaxy's ancient past, carrying the untold chemistry of worlds we've yet to imagine. It's moving fast, it came from the dark between the stars. And now, 3I/Atlas is heading for the biggest planet in our solar system, Jupiter. This is not just another comet, it's not part of our solar system. It was never part of it. Its hyperbolic orbit proves it originated from beyond the sun's gravitational reach. That means this object was formed in another star system, born under different conditions, influenced by a completely alien environment. It has traveled for millions, possibly billions of years across interstellar space. Now it's here, and soon it's going to face the gravitational pull of a gas giant that doesn't play around. Before reaching Jupiter, 3I/Atlas passed Mars on October 3, 2025. That flyby wasn't just a blip on a chart, it was watched closely by NASA's Mars Reconnaissance Orbiter, ESA's Mars Express, and the Perseverance rover. All of them caught a glimpse of a visitor older than Earth itself. They watched it from orbit, they watched it from the surface, and what they saw marked the beginning of the most critical stage in this comet's journey. Because 3I/Atlas is approaching the sun, and when sunlight hits a body that's been frozen solid for a billion years, forged in another star's cradle, things happen, things we've never seen before. This is where it gets dangerous. As the comet draws closer to perihelion, its closest point to the sun, it could disintegrate, it could flare, or it could reveal something we've never detected in any known comet. The materials locked inside its core are older than Earth, they predate our planet. They might contain exotic molecules, compounds not found anywhere else in our solar system. These aren't hypothetical, these are testable, and the data is already being recorded. Then comes the next window, November 2nd to 25th, 2025. The European Space Agency's JUICE spacecraft will be in position to observe 3I/Atlas. JUICE wasn't built for this. Its mission is to study Jupiter's icy moons, but fate has placed it in a perfect position to catch the comet as it heads into the inner solar system. The timing couldn't be better. JUICE has instruments capable of analyzing chemical compositions from afar. If 3I/Atlas contains molecules never seen in our solar system, JUICE could be the first to detect them. This might include chemical signatures from interstellar environments, materials shaped by radiation fields, magnetic forces, or stellar winds we can't replicate on Earth. Molecules formed in conditions that don't exist here. This is our opportunity to study them up close, without having to leave the solar system. But that opportunity comes with risk, because once 3I/Atlas rounds the sun, it keeps going, and in March 2026, it reaches the most dangerous part of its journey, Jupiter. The numbers matter here. The comet will pass just 54 million kilometers from the gas giant. That's close enough for Jupiter's gravity to matter a lot. And Jupiter doesn't just influence objects, it reshapes them, it pulls them, it rips them apart. It's the planet that tore apart comet Shoemaker-Levy 9 in 1992, breaking it into pieces before slamming them into its atmosphere. That event released energy on a planetary scale. Now it might happen again. 3I/Atlas is on a hyperbolic trajectory. It's fast, it's inbound, and its structure is unknown. We don't know how tightly held together it is. We don't know if it's a single solid mass or a fragile cluster of icy fragments. That's what makes the Jupiter encounter so unpredictable. There are three possibilities. The first, Jupiter's gravity tears it apart. If that happens, we could get a sudden violent disintegration. Material could scatter, new structures might form, and the breakup would give us a rare chance to study the internal structure of an interstellar object, something that's never been done before. The second, Jupiter alters its path. The planet's immense gravity could nudge the comet's trajectory, shifting its velocity slightly, adjusting its direction. It wouldn't stay in the solar system. Its speed is too great, but it could change how close it gets to other bodies, or how it exits. The third, nothing happens. It passes by relatively untouched. That outcome is rare but possible. Even then, the opportunity to observe how a massive planet interacts with a high-speed interstellar object will give scientists valuable data, and once it's past Jupiter, that's it. There is no return. The orbit doesn't bend back around. There's no second pass. It's gone back to interstellar space, back into the void. That's why every second of observation matters, because we won't get another chance. The chemistry locked inside this object could rewrite everything we think we know about how planetary systems form. It could give us insight into what conditions are like around other stars. It might even offer a glimpse into the chemical building blocks of life, formed not here, not on Earth, but light years away. There's more at stake than one object. 3I/Atlas is only the third confirmed interstellar visitor we've ever seen, and it's the most active. It's the most cooperative. The others came and went with less data, fewer instruments watching, but Atlas is giving us a chance, and the science doesn't stop once the object is gone. The data we're collecting now, from Mars, from solar observations, from the JUICE mission will remain. It will be analyzed for years, decades, maybe longer. Because this comet, this one interstellar fragment, is carrying information from another star system, from another time, from another origin. This is not science fiction. It's not theory. It's happening now. Interstellar objects like 3I/Atlas show us that our solar system is not sealed. It is open. It is visited. It is part of a wider galaxy full of unknowns. And what we've learned already is pushing the boundaries. Molecules possibly forged around other stars, behavior that doesn't match any local comet, a structure that might not survive the next few months, and a trajectory that will never repeat. All of it points to one thing: this is rare, and it matters. If we ever want to understand our place in the universe, how stars form, how planets develop, how life might begin, this is where we look. Objects like 3I/Atlas are messengers. They weren't built for us. They're not coming back. But they bring with them answers we didn't know to ask. In the next few months, all eyes will be on Jupiter, not because of what it is, but because of what it might do, because of how it might shape this ancient traveler before it disappears into the abyss. And once it's gone, the only thing left will be the data, the questions, and the responsibility to make sense of it. If this kind of science moves you, if you understand what it means to witness something that hasn't happened before, and may not happen again, then now's the time to get involved. Like the video, share it with others who care about what's happening above us, and leave your thoughts in the comments. Is 3I/Atlas just a rare rock from another system, or is it something bigger? Don't forget to subscribe so you don't miss any updates as this story unfolds. The universe is moving fast. Let's not miss what it's trying to show us. There's no turning back now. 3I/Atlas is locked in on Jupiter, a path that cannot be altered, a fate that cannot be stalled. In March 2026, it will swing past the gas giant at a distance of just 54 million kilometers. That may sound far, but in cosmic terms, that's close enough for Jupiter to reach out and leave its mark. And with a gravitational field more than 300 times stronger than Earth's, Jupiter doesn't just pull, it devours, it warps, it shreds. Everything we know about 3I/Atlas tells us this moment could change everything. Because this isn't just a rock with a tail. This is an object older than Earth, made of materials forged around other stars. Its trajectory is not elliptical, it is hyperbolic. The math is undeniable. It's not orbiting our sun, it's flying by once and never returning. It came from deep space, and once it leaves, it will carry our fingerprints with it, our observations, our data, our questions. But before it leaves, Jupiter stands in its path like a wall, one that could test this interstellar visitor in ways nothing else has, and right now, no one knows what will happen. Let's not forget what this planet has done before. In 1994, comet Shoemaker-Levy 9 wandered too close. Jupiter didn't hesitate. It broke the comet into 21 fragments, then pulled them into its atmosphere. One by one, they slammed into the gas giant with the force of thousands of nuclear bombs. The scars were visible for months. The lesson was permanent. Now 3I/Atlas is approaching with a vastly different composition, at much higher speed, and from a completely foreign origin. That makes it unpredictable. We don't know how it's held together. We don't know how fragile it is. We don't know whether it's solid, porous, hollow, or already fracturing. This is why scientists are holding their breath, because if Jupiter shatters this object, we might finally see what's inside. For the first time we could study the interior composition of a body from another star system, not through models, not through simulation, but with real observational evidence. That would be a scientific breakthrough on a scale rarely achieved. On the other hand, if 3I/Atlas survives the encounter intact, that tells us something too. It means interstellar objects may be far more robust than we thought. It could reshape how we think about planetary formation around other stars. It could confirm theories that certain types of ices, formed in colder, more volatile regions, result in unusually strong structural integrity. Or, and this is the question no one wants to ask too loudly, it could be neither. Not fragile, not resilient, but engineered. Because let's face it, this isn't just any comet, it's active. It's brightening in unexpected ways. It's carrying a coma filled with carbon dioxide, not water vapor like we see in comets from our own system. That suggests formation in a far colder, more distant region of space, or a completely different chemical process. And then there's the timing. The alignment. It passed Mars. It will pass Earth. It will pass near Venus. And now Jupiter, a sequence that feels more deliberate than random. And though there's no evidence of artificial propulsion, no visible technology, the improbability of this trajectory is fueling speculation that won't go away. Because randomness doesn't usually move with this kind of precision, none of that confirms anything. But it changes the context. Because if 3I/Atlas is natural, it's already rewriting textbooks. And if it's not, if there's even a small chance that it was sent, designed, or guided, then we're not just looking at a comet, we're witnessing contact. And contact doesn't need a message. It doesn't need language. Sometimes, presence is enough. Right now, ESA's JUICE spacecraft is watching. Between November 2nd and 25, 2025, it will have a window to observe 3I/Atlas from a position no other spacecraft can match. JUICE was meant for Jupiter's moons, but now it has a front row seat to a visitor from another star. Its instruments are powerful, capable of scanning chemical compositions, capturing signatures of molecules, detecting gases we've never seen in any comet before. This is where the real revelations might come. Because if JUICE detects molecules that don't match anything we know from our solar system, if it finds compounds that can only form in environments we can't replicate, then 3I/Atlas becomes the Rosetta Stone of interstellar chemistry, a frozen time capsule from beyond. And once it passes Jupiter, the clock runs out. Its speed, its path, they ensure it will exit the solar system permanently. Nothing we have can catch it. Nothing we have can stop it. It will vanish into the black, data stored in our instruments and nowhere else. That's the hardest part. This isn't a mission we can repeat. There's no second chance. We can't send a lander. We can't intercept it. We barely saw it coming in time to turn our telescopes. This is all we get. And yet the impact could last for generations. The data collected from 3I/Atlas won't just be stored. It will be studied, cross-checked, sat, modeled. It will influence how we search for life, how we build probes, how we design telescopes. It could tell us how stars form, how planets come together, how chemistry evolves across light years. And that knowledge will outlive the comet, because once it's gone, it will never return. But the questions it raised will remain. This is why interstellar visitors matter. They don't come often, and they don't stay. But they carry truths our solar system can't offer. They show us what exists beyond our narrow field of view. They remind us that the universe is old, active, and still full of surprises. And more than that, they force us to look up. Right now there are engineers, scientists and astronomers working across continents to capture every frame, every signal, every echo of 3I/Atlas, agencies that don't always work together
or coordinating.
Instruments are being repurposed. Mission plans are being updated, because when an object this rare comes through your front yard, you don't let it pass unnoticed. And that collaboration, that urgency, might be the most important legacy of all, because 3I/Atlas is showing us what's possible when the world pays attention, when we stop arguing about what's likely, and start preparing for what's real. The questions won't stop when it's gone. If anything, they'll grow louder. What star system did it come from? What conditions shaped its core? Why is it active the way it is? And what does it mean that we're now seeing multiple interstellar objects in just a few years? Is it chance, or is it something else? 3I/Atlas doesn't need to answer that question. Its presence is enough to change how we ask it. We're witnessing a moment that will be studied for decades. A visitor from deep time, passing briefly through our system, under our observation, and though it won't touch Earth, it's already altering the way we see the sky. This is not routine astronomy. This is a once-in-a-generation opportunity to reach across the stars and learn something about where we came from, and where we might be going. After Jupiter, there is no encore. 3I/Atlas will not circle back. It won't slow down. It won't loop around for another pass. The comet's hyperbolic path guarantees that once it clears Jupiter's gravitational grasp, it will head for the edge of the solar system and beyond, into the deep dark void from which it came, outbound, forever. And when that happens, the trail it leaves behind won't be visible in the sky. It will be in the data, spectral lines, velocity curves, compositional analyses, terabytes of raw numbers that scientists will pore over for decades, trying to reverse engineer the journey of a fragment that may have formed before our own sun ever lit up. Because that's the part that's easy to forget. This comet isn't just from another place, it's from another time. It may have been wandering between stars for billions of years, each orbit around the galaxy. It may have passed hundreds of solar systems. Ours is just the latest, and it might be the first with telescopes capable of recognizing it for what it is. That's the weight of this moment. What 3I/Atlas carries is not just ice and dust. It carries a record of chemistry from regions of the galaxy we've never visited. Materials shaped by other suns, other forces, other rules. Its surface has been scorched by cosmic radiation, bombarded by interstellar particles, and frozen in silence for millennia. And now, for the briefest period in its incomprehensibly long life, it's within reach. This is the part of science that rarely makes headlines, but it's where discovery lives. Because when JUICE gets its chance to scan this object, when data comes in from Mars orbiters, from telescopes trained on its coma, the results won't be flashy, they'll be quiet. Technical, numbers that don't immediately scream significance, but buried in those numbers might be a molecule we've never seen before, a chemical structure that doesn't form under solar system conditions, a clue to how planets are born in other corners of the galaxy. It's not about spectacle, it's about access. And access is fleeting. Every mission team involved in observing 3I/Atlas knows what's at stake. The comet won't wait for calibration. It won't pause for bad weather. It won't care about funding cycles or data backlogs. It's moving on. It always was. And still, despite the precision of modern instruments, and the coordination between agencies, so much about this object remains unresolved. We don't know how it formed. We don't know if its activity is typical for interstellar bodies, or if it's a rare outlier. We don't know if it will survive Jupiter's pull, but we do know it's unlike anything we've seen before. Not because it defies all natural explanations, but because it forces us to consider that our explanations might not be complete. That's what makes this moment uncomfortable and exciting. This comet has passed Mars. It's passed the inner solar system. It's seen our worlds from a distance and left no mark. But now it approaches the one planet in our system capable of altering celestial fate, Jupiter. Whether that encounter ends in violent fragmentation,
a minor trajectory shift or nothing at all. It will be the last major interaction before Atlas disappears into the interstellar dark. Every outcome tells a different story. Every possibility adds to our understanding of what space is capable of. If 3I/Atlas breaks apart, we'll learn what holds together an object born far beyond our star. If it bends course, we'll gain insight into gravitational interactions on an interstellar scale. If it sails through untouched, we'll witness just how resilient a visitor from another star can be. But if we fail to capture that data, if the observations fall short, then we lose more than a scientific opportunity. We lose a once-in-a-lifetime connection to something older, colder, and more mysterious than anything made in our solar neighborhood. The legacy of 3I/Atlas won't be marked by fireworks or impact events. It will be in the silent transmission of data, in the charts, the models, the code, in the research papers written decades from now, citing findings born from this brief encounter, in future missions that are sparked by the questions this object leaves behind. So what does this all mean for us? It means we're watching history in motion. It means we're living through a rare moment of astronomical alignment, when ancient ice, planetary giants, and human curiosity all converge in the same sliver of time, and it means we have a responsibility not to waste it. If you're still here, still thinking about what 3I/Atlas really is, then stay engaged. Like the video, share it with others who need to know what's unfolding. Leave a comment with your thoughts about what this object might reveal, and don't forget to subscribe. Because the closer we get to Jupiter, the louder the silence of space becomes. And in that silence something is waiting to be learned.